had lots of questions on number 8, and it's kind of a difficult question, so it's definitely worth doing here for you guys. It says that a water rocket starts from rest and rises straight up with an acceleration of 5 meters per second squared until it runs out of water 2.5 seconds later. If it continues to rise until its speed is 0, what will be its maximum height? So let's just draw a quick picture of what's going on here. So we'll draw the ground, and we'll draw a rocket here. Put some fins on that thing, and it's going to take off upwards. And they want to know what's the distance that that rocket travels into the air. Well, there's a couple of things here. Let's just talk about what we know is true. We know it's going to accelerate upwards for some rate, and then it's going to run out of water, and it's going to stop accelerating at that initial 5 meters per second squared, at which point it's really just going to be coasting for a second part of this. So we've really got part 1, or stage 1, and stage 2 here for this rocket taking off. And it's going to reach some speed, and then it's going to start this second phase at that speed and then coast to a stop at the top. So we kind of have to think of it like it's going to pick up speed, and the final velocity for stage 1 is going to be my initial velocity for stage 2. So we really have to find two distances. We have to find distance 1 for this part. We have to find distance 2 for this part. So let's just go ahead and work through the problem here. I know that for this stage, my acceleration is 5.00 meters per second squared. And I know it's going to be doing that for a time of 2.50 seconds. The rocket also starts from rest, so my initial velocity is 0 meters per second. And so let's go ahead and solve for part 1 here. The distance for part 1 is going to be equal to the initial velocity times the time plus 1/2 at squared. Because my initial velocity is 0, this term really disappears, and I'm just going to have 1/2 times 5.00 meters per second squared times 2.50 seconds quantity squared. So let's go ahead and punch that in. 2.50 squared times 5 times 0.5 gives me 15.625 seconds quantity squared. So that's going to be seconds squared and seconds squared, bottom and top, so they cancel and I get meters, which is good because I'm looking for the distance or the height that this rocket goes. Okay, so we found how high it goes in part 1. Let's talk about part 2. Now it's no longer accelerating at 5 meters per second squared. Now even though it's still going upwards, the only force it's experiencing, if we ignore wind resistance, is gravity. So it's in free fall. So the acceleration is going to be negative 9.81 meters per second squared. And I know that the velocity at the top is going to coast to a stop, so my final velocity is 0 meters per second. My initial velocity is the final velocity here, so I kind of have to go back to these numbers and say, well, what's the final velocity for stage 1? Because that's going to end up being my initial velocity for stage 2. So my final velocity is equal to initial velocity plus acceleration times time. In stage 1, the initial velocity is 0, so this term is going to go away, and I have 5.00 meters per second squared times 2.50 seconds. Okay, this second cancels, one of those seconds cancel, and I end up with 12.5 meters per second. Okay, so now I know up here, I'm kind of out of space here, that my initial velocity is 12.5 meters per second. So let's find out the height that it goes in part 2. Well, I don't have a time here for this one, so I can't use the time formula that I used before, but I do have another formula here. Final velocity squared is equal to initial velocity squared plus 2AD. Now that's the version I remember, and I just solve it when I need it. In your formulas page, you could have this rearranged for whatever you need it to be, but since we're looking for distance, We'll do a little algebra magic here. Oops, to A. And then we'll just punch in what we know. Well, if my initial velocity is 12.5, my final velocity was 0, so this goes away. Now note that that negative does stay, and the signs here are important. So I'm going to have negative, and the initial velocity was 12.5 meters per second, quantity squared, all over 2 times negative 9.81 meters per second squared. Okay? So 12.5 squared is going to give me 156.25. And I'm going to go ahead and do the units here. Meters squared per second squared, all over. And that's negative because that was out front. It wasn't inside the box getting squared. It was outside. So this is still a negative term. Then I have 2 times 9.81 negative. So I have negative 19.62, and that's meters per second squared. My negatives cancel and leave me with a positive number. So I'm going to take 156.25 divided by 19.62. Oops, I think I've done the math wrong there. 156.25 divided by 19.62. There we go. That looks more realistic. 7.96. Second squared cancel. This meter cancels. One of those meters cancel, and I'm left with meters, which is good because I'm looking for a distance. So here's my height from stage 1. Here's the height that it goes during stage 2. We'll just add those together. 15.625 plus 7.96, and I get 23 point, and we're going to keep 3 significant digits, so 23.6 meters, and that'll be the height that that rocket goes during those 2 phases of the launch.